researcher for network infrastructure, and he's going to share his view, experience on using AI/ML for a specific use case, network optimized DDoS mitigation.
All right. Hi, everyone. So in this track, which is not about security, so let me take a moment to talk about security. So the problem that we are facing that I'm looking into is really about DDoS. And when we look at DDoS, it's really something that has been changing over the past couple of years. So in the early days of DDoS, it was really about traffic that was spoofed. So something that was coming from a few number of hosting providers that were allowing and not filtering traffic. It was leaving the networks. And also a lot of misconfigured services, a lot of them UDP-based, that were abused by attackers. This has been changing, so not suddenly, but really gradually over the past couple of years. And now what we are seeing, based on data that we have been working with our customers, is that based on the sampling of thousands of attacks that we have manually inspected, we are seeing that now DDoS is really coming from botnets. So instead of coming from this small number of hosting providers not filtering traffic, it is now coming from hundreds of thousands of IoT devices, cloud servers, and other unsecured devices. And really what is shifting now is that starting a few months ago, we are seeing that the majority of DDoS today is actually botnet sourced. So something that is really different and really different to mitigate against compared to what we had before with spoofed traffic. So that's what we see here on the right, where botnet is the majority of DDoS attack bytes, that it is the majority also of complex DDoS attacks because botnets are required for most application layer DDoS. They can also do very damaging volumetric DDoS. And what we're seeing here on the graph is really that it's been a steady progression. We've had a blip last year. I'll let you guess why. So we've seen some nation-state actors also getting involved with larger botnets, but overall it's been a steady growth, and we see this really taking the majority of traffic. Now, what's very different about those bots is first, they are spread geographically. So it's not just 1 or 2 or 3 countries that are sourcing this DDoS traffic. It is devices that are spread across virtually every single country. So we see digital video recorders, so many of them. So it's almost practically the majority of them that we see. We see even a bit more recently some devices in medical imaging. We see some cloud VMs that are being exploited as well. You may have heard, for example, of course, of Log4j last year, of GitLab. So really something where cloud VMs, servers, VPSs can be abused into sending DDoS. Those can inflict a lot of damage. And something that we are seeing also is that, of course, there is a large number of them, but they don't attack all at the same time. So they tend to attack in smaller packs of bots, so what is typically part of single botnets, and something that, of course, is going to be taking a larger and larger share as time moves on. So now, based on the data that we see, so we are keeping track of around 500,000 active bots. They are likely about double that amount. And we estimate, based on the data that we see, that we have sampled from those DDoS attacks, that there is a potential for around 50 tera to 100 tera of attack capacity. So if they were all to attack at the same time, so this is roughly the amount of bandwidth that we would face for the victim. Now what we see practically is that we see routinely now 1 to 2 terabit per second attacks. Of course, we see also a lot of smaller ones. But for a typical attack, this is really what we're going to be looking at. Now for these attacks, so most of them are just in the thousands of bots in terms of number of sources. So we're not talking here about a very large number of bots attacking at the same time the same victim. It's only very rarely, and we've seen that again in the context of geopolitical tensions here, that there are some botnets that can be deployed with more than 60,000 devices. We've seen that in Europe. We've also seen that in Asia in last year. So, and we can see again here the distribution. So again, many of them are just from hundreds to thousands of devices, so something that we can really address at the network level. Now, something also to acknowledge, because I think this is also part of the problem, is that we are still, even though the botnet is the majority of DDoS traffic, it is still the early days. And what we are seeing here is that for many of those devices that are compromised, they are accessing the internet through asymmetric internet connections. We see, especially, for example, in the US, still some internet connections that are deeply asymmetric, where we have, for example, a gig of downstream and then maybe 50 megs upstream. This is changing, right? So we see, of course, we see this in Europe and in Asia, where we have some symmetrical plans for bandwidth. But this is changing also quickly in the US, which is, by the way, the major source of DDoS today. So today, what this means is that botnets are constrained by the upstream bandwidth, and this is changing. So the potential that I mentioned earlier for the 50 to 100 tera of DDoS attack potential, this is going to go up. Now, so why is this such a problem? So because this is really what we're looking at here. So the other problem is that today, so many of our customers or service providers have been really protecting the peering edges of the network, which is, of course, because they want to protect their infrastructure and their enterprise customers in particular. Now, when we look at botnets, as we say, the call is coming from within the house. There are thousands of devices from within the operator perimeter that are now can target its network. So this is something that can be coming from within the subscriber edge, for example. And we have seen examples where, for example, in very large distributed carpet bomb attacks, where, for example, it was targeting one specific country, and about a third of the DDoS attack traffic was coming from within the same operator. So it can be something really damaging from within the operator. And as we can see, so before we were seeing DDoS coming from a handful of countries that were allowing for spoofed traffic. Now we see very different types of countries that are sending DDoS, because this is where we have large internet upstream and also where we have large number of IoT devices. So this is how we see here that we have the US in first place, so the US is the largest DDoS exporter today. All right, so how can we address this? Because that's why we're here today. So I know that historically it's been a lot about traffic baselines, rate limiting traffic as it comes in or goes out. But we think that, of course, this is an answer, but this is not the answer. So now what we are doing, and there are a couple of things that we can do to really address the problem. One is going to be first that we can categorize traffic based on a large data set that continuously evolves. So this is not really about going into looking what is in the packet, or what is really the structure or the common features of a flow of data, but instead going to see what is sending this traffic, what is the source, what is the type of devices that is sending this traffic, because this way we can have much more confidence into classifying this as botnet. So this is going to be a key part of reducing the false positive rate, which rate limiting, of course, is not very good at. The second thing is that we can address this by using some form of AI to make sure that we can take multiple large data sets into account to make a decision in real time on the network, so that we can take, for example, into account what is the breakdown of attack vectors for the attack, what type of mitigation devices and resources are available on the network, and so that we can also output something that can be understood by those devices. Because of course we know that it is not going to be a mono-vendor type of environment, and we need to be able to address that with the network resources. And finally, also something that is becoming more and more relevant with botnets is that we need to be able to predict also which type of devices are going to be attacking the victims. And for this, we need to be able to do some clustering to understand what bots, what botnets are actually attacking, so that we can preemptively also include into the filter on the router side the source IPs that are that are attacking actually the victim. And so finally, on the other practical example of what we can do in terms of addressing the botnet problem, this is really also something that is, let's say, part of the industry, where we can actually measure the effectiveness of those solutions, so those practical applications of AI and ML into DDoS detection and mitigation, and to really measure against a body of actual samples. So this is something also that we have been doing with our customers, so that we can continuously evolve the models for detection, but also for mitigation, and then also show very practically what is the false positive, what is the false negative, and how we can really collectively address that as an industry. All right, so in summary, so it's really, again, the early stage. So I know that it is the majority of traffic today, of DDoS traffic. It is still the early days, so we can have, we can do something to really get prepared for that, what's coming. And this is something also that is really going to concern every single service provider, and that is coming from within the networks. We need to be able to detect, not just at the peering edge, but to be able to classify this within the network, within the subscriber edge, the data center edge, and others. And we have now some tools. So of course, this is continuously evolving, but we do have tools that we can address to use to address this problem. All right, thank you very much.
Thank you very much, Jérôme. A question for Jérôme in the room. Yes, please. We'll just wait for the mic. It's coming.
Hi. The danger for the service provider is clear. We live with the DDoS attacks on a daily basis. The question I have is, if you are in the face of a volumetric attack, typically the carpet bombing, which is the biggest danger right now, if I have a machine learning algorithm which dynamically decides how to mitigate an attack, so I don't really have a fixed settings, what am I going to say to my customer when I have black holed his IP address, his destination? Based on what criteria I have mitigated the attack? Because next day he's going to say to me, okay, you need to tell me someone else makes the decisions, it's not you. So who is this? Is this a moving target? How are you going to address this problem?
Sure. So of course the goal is going to be to avoid black holing. So this is something that really we want to, so this is one of the reasons why we want to measure the false positive rate, because black holing, anybody can do black holing. Yes, yes. So, yes. So one of the things that we are trying to limit is really black holing, so that we can, instead of looking at the destination, so we use these models to instead block very granularly the sources of the DDoS. And in the case of botnet DDoS, so this is not going to be spoofed. This is going to be coming from real IP addresses. So we can actually block those, especially when we combine that with the capabilities of modern routers today. So this is something with the current scale of the botnets that I mentioned. So this is something that is within the reach of routers, right? Because we're talking about at the maximum tens of thousands of source IPs. So this is something that most modern routers today can manage, right? So this is the goal, to avoid the black holing, as much as we can, and we actually really don't do that now, but really instead take a much more granular approach that is afforded because we have those type of techniques.
Thank you very much, Jérôme.
Thank you very much.
Thank you.